Hello SGD, Sacred Geometry Decoded. Do a drawing exercise and I'm going to draw a Nonagon. Now, technically impossible with compass and straight edge to do it perfectly. We're going to design one so accurate that it's thousandths of a degree, so less than the thickness of the pencil, so indistinguishable from perfect. Now, purely mathematically speaking, impossible, but we're going to get really close with this Nonagon. I come up with another Nonagon design. This one's even more accurate. And so we'll begin with a construction line. Should be roughly okay. Should be able to. I'm going to begin with a construction line, and the camera. Yep. Okay. Now we're Vesica Pisces, excellent template because you have a construction line, then you have 90 degrees from there, but it's actually the 2 to 3 ratio of the Vesica, which is the important part here, and then we'll go on to do, I might, 2, so 3 be roughly there. Okay, actually I might just sneak it in. So what I'm going to do is reverse the paper around just to make sure I've got enough room to fit it in, because part of the construction is a Fibonacci Spiral. I'll put a link in the description. I come across this design by looking at the geometry of the 3 Giza Pyramids and the Pyramid of Menkaure. Now, begin with a Vesica. And 1, 2, 3, and of course 1, 2 high. So we have a 3 to 2 ratio, 2 and 3 being a Fibonacci numbers. So now I'm going to go on the end. Now hopefully it'll work. You need to be, oh, should have kept that there. Okay, when we mark an arc on the bottom, we do the same on the other side. I just want to create a rectangle enclosing the Vesica. Okay. Now at this point I need to find the 90 degrees from there, and I'm going to put my point, then adjust the, actually I'll do it on the other side so it's not in shadow, and so now I can try and adjust my ruler as precisely as I can. And actually now I don't need, I'm going to draw the construction line as long as possible. Actually should have carried it up a little bit more, but the ruler's a bit short. And so we've got marked those arcs. Now we need to adjust the size of the compass so we find the center. Get my head in the camera. Again, I'm just sort of illustrating the technique. You really want to take your time, be as accurate as you can. Alright, so get a little bit closer, that if I do it right it should, now I can see, okay, I take it out, I see that the hole's just a fraction of a millimeter off, so I want to really get it in. Okay, we adjust that, very close. Okay, now we've got it. So now on, so we've got that center line there, and what I need to do now is mark those particular arcs. Actually, I missed a step. I need to go back. So let's find the center of one of those circles. I actually missed a point. Okay, now before I adjust my compass, let's get it back to the original setting. Okay, then I find the center. Okay, I mark that at the top. Mark that at the bottom. Now I readjust my compass, put it at the center of the Vesica there, find the edge, make sure I've messed up the pinhole in the center a little bit, so let's just try and get it as close as we can. Yeah, that's because of my point now has sort of created a large hole there in the center, and it's going to slip around. But okay, so with that there, now I'm going to place it on these markings here in the center I made. do that again on the other side, go to the top and do the same. And so I've created 4 points that encloses a vesica in a rectangle. Again, I'm sort of, usually when I'm drawing I'd have my head close up and I don't want to get it in front of the camera, so but if you are doing it, just follow the lines, and the technique, just, you know, be as precise, accurate as you can. I'm going to slide that up a bit because I want to extend that line upwards. Okay. And do the same on the opposite. And now from that point to that point there, that point, and we've created an enclosing rectangle, and with that we can start to do a Fibonacci spiral, because it's, the vesica itself is a 2:3 ratio. So here we have the rectangle, and actually what I'm going to do is extend these lines out as well, just to help with the later portion of it. Okay, 1, 2, and then 1, 2, 3. 2 to 3 wide, 2 to 3 Fibonacci sequence. Now, what you'll notice is, okay, so I'm actually going to sort of draw in and darken up the Fibonacci spiral to begin with. So the golden ratio, as I call it. So no, that's a quarter circle. Okay. Now I do another quarter circle. Now at that point, okay, I won't actually do a full construct, but what we have is a 1 to 1, 1 to 1. So now it's a 2, 2 to 1, and then I'm just eyeballing that, but now we have a, I'm going to adjust it there. So now another quarter circle. Oh, that's way off. That's it. Okay, so there's another quarter circle. So a quarter of a circle, quarter of a circle, now a quarter of a circle, and we go to this top point. I adjust that out, and I add another quarter of a circle. Okay, a bit of a glitch, let's keep going. So quarter of a circle, quarter of a circle, now we have another quarter, 2 to 3, so the next would be a 3 to 5, so 2 to 3, so I adjust the compass to the long edge, which is 3, and so now 2 plus 3 would equal 5, and we could just do a quarter of a circle straight away. A little bit out, it doesn't matter for the moment, just trying to illustrate it. Okay, I mark that top there, and now I extend that line out. Okay, so now we have a 5 to 3 rectangle, and now extend the compass and make it 5 long, and we do another quarter circle. Okay, there we have a Fibonacci of 5 by 8, and I'll just use it setting while I got it to mark it off. Is that in camera? Yep. Okay, 5 to 8. So Fibonacci spiral beginning with a vesica. Now we have a 5 by 8 rectangle. This is all we need, because now the diagonal of this 5 by 8 rectangle, oh geez, just touch short. Okay, 5 by 8 rectangle. The diagonal of that is going to be 32 point, I think it's 008 degrees. So 32 and thousandths of a degree is the diagonal. So that's I'd have to double check, but I think it's something like 32.880 degrees is this angle. The angle we need to create a nonagon is 40 degrees. So what we can do now is begin the construction of the nonagon. So find that corner there. Now I can adjust the compass down. I want it to fit on the page. Alright, so this is the circle. I'll just darken that up. Center of a circle, that's where we'll be using the nonagon. We have 32 degrees, and so what we need to do is bisect that angle, which you can do with compass and straight edge. And so to bisect the angle, I want to cut that angle in half. Just make sure the compass is, you can eyeball it, just make sure it's over halfway. I draw an arc. I go to the bottom and repeat. We've cut the angle in half, so now we have and let's just call it 16 degrees for now. It's not exactly precise, but thousandths of a degrees. Even the finest pencil won't catch it up. So, and what we need to do is cut that angle in half, bisect that angle. And so that would be 8 degrees. So this angle here is 8 degrees. We can find that, set the compass to that. Okay, now we add 8 degrees to 30. Therefore now we have, well, essentially it's 40 degrees, which is the core central heart angle of the nonagon. Okay, so now this angle should be 40 degrees to within thousandths of a degree. So now let's set that compass to that 40 degree section. I'll check this on GeoGebra. It's, yeah, so it's not, but again, thousandths of a degree off. So, okay, there we've set that, and so we just can run that around. I've got all in camera. Again, take your time. If you do it, it's super accurate, be precise, it'll work, again, so less than the thickness of the pencil. But so just trying to, again, as I'm drawing with the camera in the way, it makes it a little bit hard to, and just for time as well. Okay, now this final one should touch on there. Well, it's actually a little, it's a fraction off, but if I had done it properly, so let's run it around again. Okay, actually I should have make that a little bit bigger. Okay, there you go. I should have, I'll make the, so I'm going to use that second point. And I'm still running it, well, you get the key point because this original one, doing the illustration of it, but so I'll be using this point. So we have 9 points. To create our Nonagon. Now at this point, because I'll erase the pencil marks underneath, and I'm going to shift to permanent markings. Okay, alright, pen's working. Interesting thing about the Nonagon, it's the first polygon or star where you can break it into 3 regular polygons. By that I mean 9 divided by 3 is 3, so it's free. One way to draw it is 3 equilateral triangles, and to do that we just go every 1, 2, 3 or third point. So I'm going to draw an equilateral triangle, and 1, 2, 3. Now it won't be a perfect equilateral triangle. There's a few thousandths of a degree off, but there would be one, and so again the next one would be 1, 2, 3. So we're creating like again a nonagram, a 9-pointed star, but you're able to divide it up into 3 regular polygons, equilateral triangles. That's like the next one would be the 12-pointed star, because you can make 3 square. 12 divided by 3 is 4, so you could use squares, but this is another interesting point about the Nonagon. And their equilateral triangles, you might notice they look a little skew-if, but once we put the third one in there, we'll start to get the shape going on. Again, if you do this again really carefully, take your time, you'll find that it will work very, very nicely. Again, I've tested on GeoGebra, but it's also the 2-to-3 ratio, which is the Capra's pyramid, 8-to-5 ratio, which is the Menkaure pyramid, and from that same spiral you can get the Lucas numbers, which brings you to 7 and 11, which is the Great Pyramid. So there we see one way of drawing a 9-pointed star, which is 3 equilateral triangles. I forget the term for this, but being like the pentagram, if you draw a pentagram, it's like you can draw it in one line continuously. If it's a 7-pointed star, you can draw it in one line continuously, and so we'll draw that star on top of there. And the way to do that would be just to pick a point, find it's closest to the opposite side. It won't go directly through the center, but you can just eyeball which one would be directly opposite. And there, and then so the idea is now I'll never actually have to take the pen off the page. I'll go from point to point and just work my way around. Now, for instance, a hexagram or a 6-pointed star, to draw an equally balanced one, you do need to take the pen off the page. For instance, you need to do 2 equilateral triangles, but odd numbered stars, 5, 7, 9 as we're drawing, or 11, they're ones where you can just, again, there's a term for that. I highly recommend the Geek 37 channel if you're into your geometry, because he talks about these things as well. I don't want keep my ruler on. Go back to the original point. Roll it down, and there, I believe that's it. Okay, so now we also have the hexagram sort of 9-pointed star. Now a further step, so we sort of know where the center is there, but also these troughs, these chevrons here, each one would allow you to cut the angle in half. So now you could, for instance, do a 18-pointed star. Oops, what was I thinking? Sorry, that's totally off. That chevron points to the opposite side, the opposite point. So that's the line we want. That chevron there should run through the center and touch the point of a star on that side. Run through there. Just run it through the center again. It'll touch that point of a star up there. So we'll just bisect. Actually, that's a little bit off. I'll just hand freeze that. I'm just doing it too quickly at the moment. And that original construction line, just follow that through. And this chevron here. Okay, so now we've created an 18-pointed star, and especially when I rub away these construction lines. But now we can do another one just to show. So we've got the 9-pointed star there, and okay, I just need to reset the camera before it glitches out. Okay, so 9-pointed star, I actually forgot one here. So that will run through that chevron there. So now we have an 18-pointed star. And what have I done with my eraser? Okay, shouldn't need it just for the moment. So 9-pointed star, just for the nice geometry terms. Each one will be, so again, we're not going to go actually through the middle, so I'm going to go from here to here and then back to here and then just work the 9, so we're going to draw an 18-pointed star. Point. Oh damn, totally messed that up, ruined it, but it's okay. Whirl your way around. Next one is up there. There's no royal road to geometry. Just showing this because I just want to sort of show, especially in the center there, is whether it's a 5, 7, 9, doesn't really matter there. This really nice sort of cool looking geometric symmetry and patterns will start to emerge. So I like that. Complexity is just a repetition of simplicity. Oh, again, let's get that. So you might have seen some really complex sort of geometrical drawings, but what you find is that they're actually just beginning with a simple shape, a simple star shape, and just repeating itself, and it starts to create this pattern. Now there's a little bit of asymmetry there because if you remember I began with 3 equilateral triangles, so I'm going to go back to, so you might note these skinny ones, let's balance them out with an equilateral triangle. So I'll skip 1, 2 and 3. And 1, 2, 3. And then we go back to the original, which should be 1, 2, 3. If I'm correct, I think it's right. Yep. Okay, so now we have V. So let's get with that one. And I would go directly to that one. Now, would I? Oh, yes, I think I would. Because we've missed 1, 2, actually no, sorry. It's a little bit tricky now, so I'm actually going to mark these out. So I want A, and that would be A, so that would be B, B, B. Okay, just to make it a bit easier to follow those around. Okay, now we're just going to do, that's the equilateral triangles. This extension to make it an 18-pointed star, it's just for showing off really for no real purpose, because we've already done the 9-pointed octagon. Nonagon. Nonagon is a 9-sided polygon. A nonagram is a 9-pointed star. So now we have an 18-pointed star, which probably has a name which I can't think of as, you know, wouldn't be isocosa, but like isocosa, decadenta, megadenta sort of, you know, things in Greek. But there we have the core of it. Where's my eraser? Clutter everywhere. Alright, now. So we have all those construction lines underneath, but we can just take those away. Still a bit wet ink, but that's okay. Channel your inner Bob Ross. And a few little glitches along the way, but what we have is the 18-pointed star. I'm wondering why there's a little bit of a... Anyway, that's whenever you make a mistake, call it an Easter egg and say it's up to the student to work that out, because that should be symmetrical in there. I've missed a step or a stage or sort of skipped one over while I was doing it. But wouldn't have been a problem in the 9-pointed star, but there's a 18-pointed star, and there's some homework for you to work out why that one's not all nice and symmetrical in the corner. I know why. I'll leave that to you though. Alright, so that's a drawing exercise. Nonagon to an 18-pointed star with a... Actually, yeah, it is. Look, it is an egg in there as well, so I can legitimately say it was an Easter egg. Alright, with that, hope you enjoyed. Have a